Hello everyone. Today is the last lesson in this unit. I know it was a pretty quick unit, but that's totally okay. After today, for the next 2 days, you're going to be working on a project. Each of you are going to be given different sets of data to analyze and to create regression equations for. So today we are going to apply data to real world situations. So let me make sure I get all presented for you. We're going to be really working on Desmos today and making sure that you guys are able to do all of this. So looking at our worksheet for today, here's our worksheet. We're working on regression application, and we're going to be able to find the line of best fit and use it to predict future values. So a trend line is a line on a scatter plot drawn near the point that shows a correlation. It's when you just basically sketch in a line that follows the points. Now, the line of best fit is the official trend line that shows the relationship between two sets of data most accurately. And that's what we find on Desmos when we use Desmos. Interpolation is the estimating of a value between two known values. So when I have a bunch of values and I'm going in between those values to determine, an extrapolation is predicting a value outside of the range of the known values. So if I have numbers in the x's from 2 to 6, but I want to know an x value of 20, that's outside of 2 to 6. All right, so we have a table right here, and it says the relationship between the number of widgets in a package and the length of the package in inches is given at the table at the right. What is the slope of the line of best fit? Well, to figure that out, we need to create it. So first we're going to come into our Desmos just like we did yesterday. We're going to add in a table. We're going to put in the x's. Remember, the x's are almost always on the left-hand side. I, in fact, cannot think of a table where they were not on the left-hand side. And then we're going to put in our y's. I'm going to zoom in a little bit because I was zoomed out still from last video. And then I am going to write my equation. And I'm going to put that equation up here for you guys. But it's y1. Remember, squiggly line, which is right near the 1. You press shift the button to the left of the 1. And then mx1 plus b. Remember, to get that lowercase, all you do is type the 1 after the x, and it automatically does it. So right here under parameters, we have our m, which is, I'm going to put it on my paper, make sure you're writing it down too, 0.25. And I have my b, which is 8.25. So I'm going to go back to my screen. I have written down my m and my b. And the first thing that I'm asked is, what is the slope of the line of best fit? Well, we know slope means m, and my slope is 0.25. So m equals 0.25. But we're going to actually say what it means in context. What does this mean in context? Remember, slope is y over x, and we write this as x increases, what does y do? Y blank. So as the number of widgets increases by 1, as the number of widgets increases by 1, the length, and it should be by 1 widget, but the length of the package increases because it's going up because this is a positive slope by, and we go to what our slope number is, 0.25 inches. Almost always your x is going to increase by 1, and then your y is going to increase by whatever the slope is. The other thing I did tell you is I was going to write down the equation up here, so let's make sure I write down the equation. It's y1 squiggly mx1 plus b. I would make sure you write down that equation so you know what to type into Desmos. Okay, now let's talk about the value of the y-intercept of the line of best fit. Excuse me, I sneezed there. So the line of best fit is the y-intercept is 8.25. So now that we know that the y-intercept is 8.25, what does that mean in context? It means that when the number of widgets is 0, when there are no widgets, the package is still 8.25 inches. When there are no widgets. The package is 8.25 inches. So that's just the base size of the package. Okay. And if we were to write this in an equation, it would be y equals 0.25x plus 8.25. I'm going to have us go back to Desmos real quick to make sure we look at that correlation coefficient. Everybody look at the R under the y1 equals mx1 plus b. And we see that R equals 1. That means that every point is on the line. So this would actually be a true linear equation. It's not a scatter plot. Every point is on the line. All right, let's go back to our equation. The table shows the relationship between total fat grams and the total calories in a selection of fast food sandwiches. Find the linear regression equation that models this data. And this asks us to round the nearest to the nearest integer. Now, integer means whole number. So we're rounding our slope and our y-intercept to the nearest whole number. Since we have to write an equation, we know we're finding slope and y-intercept. So let's type this into Desmos. Okay, so I have 9, 260, 13, 320. The nice thing about Desmos is that these don't have to be in order. Bugaboo wants to come say hi to you guys. She's missing out. Do you guys want to see Bug real quick? She says, I'm missing out. I'll stop presenting. See, this is Bugaboo. Her name's Bug, but I just call her Bugaboo because she's so cute. Or she's the orange cat. I think I told you guys that already. But she wanted to come say hi. When she wants to come say hi, you just gotta let her come say hi. So hopefully I can keep working through all this. We'll see. Okay, let me go back to presenting real quick. Oh, hi. She's giving me kisses. All right, coming back over here. We were at 21, 420, 30, 530, 31, 560, 32, 580, 34. If I can type it right. Still can't. 590. And I see 7 up here and 7 down there. Now I'm going to zoom out majorly because this is in the hundreds and we might not be able to see. So here we go. I see my points now. Now this, as we increase, we're increasing. What type of association is going on? Hopefully you said a positive correlation. Bye, Bugaboo. All right. So let's go down here to our slope. Remember, we're rounding to the nearest whole number. So our slope would be 13. And our y-intercept nearest whole number is 143. That 5 after the decimal tells me it's 143. Let's also look at our correlation coefficient. For this one, it's 0.9984. That is so close to 1. And as you look at these points on Desmos, they're so close to the line. They're touching the line. So this is extremely strong positive correlation. So now that we have those, we're going to go back to our worksheet. We can write our equation, which is y equals mx plus b. I'll put that up here for us to remember. So it's y equals 13x plus 143. This is why we did so much work with y equals mx plus b at the beginning of the semester. So now let's talk about what these mean in context. This is my x. This is my y. So my y-intercept means that even something with 0 grams of fat is going to be 143 calories. And that does happen. Even if it has 0 grams of fat, sometimes it does have calories. And then the 13 means that as the fat increases by 1 gram, the total calories increase by 13. You could also say as total fat increases by 1 gram, it goes up 13 calories. So that's how you would say it in context. Number 3, a morning radio talk. Gosh, I have some typos today. Talk show is running a winter coat campaign to collect and deliver that should say coats, to local shelters. They are storing the coats until they reach their goal of 2,100 coats. That's their goal. The table at the right shows the number of coats in storage at the end of the day of the campaign. Write the linear regression equation for this data, rounded to the nearest. This time we're rounding to the nearest 100. All right, so let's put our data in. We need to get rid of this data. Okay, and I'm going to put in the new data, 1, 860, 2, 930, 3, 1000, 4, 1150, 5, 1200, 6, 1360, and that's it. Oh, we might have to zoom out some more. Whew. And here's our line. We have our line. One thing you guys can do, if I remember, if you see this little zoom fit here on the left side, it was, sorry, I just did it. So it was a little magnifying glass right at the bottom of the blue over here on the left. Here by the table. There was a little magnifying glass there. I touched that and it fit the graph to my scenario. So now that I have this, we can see the points and how close they are to the line. They're very close to the line. And if we look at our correlation coefficient, it's 0.99. So it's a very strong positive correlation. And we need to write our slope and our y-intercept. Remember, our slope, we're running to the nearest hundredth, is m, so that's 98.86. And our y-intercept is b, so it's 737.33. Now coming back, let's write our equation. Y equals 98.86x plus 737.33. So let's talk about what this means in context. That day 0, at the very beginning of the campaign, they already had about 737 coats stored. And that they are each day of the campaign, so as one day goes by, or the X increases by 1, the number of coats stored increases by about 99 coats. That's the Y. Okay, now using the equation from part A, predict the day the campaign will meet its goal and the coats will be delivered to the shelters. So they want a total of 2,100 coats. And I need to find out the day. I need to predict the day. Remember, day is X and this is Y. So if they want 2,100 coats, because that's what it says in the original, 2,100, I need to know the day, so X is unknown, is equal to, and I'm using my equation, 98.86 X plus 737.33. So we're going to subtract 737.33 from both sides. And I'm going to use my yellow calculator for this because it's going to be a little bit easier. You can do this in Desmos, and I'll show you that in just a second. But 2,100, if I turn it on, 2,100 minus 737.33 is, oh, not plus, sorry, 2,100 minus 737.33 is 1362.67. 1362.67 equals 98.86x. And the thing is here, you shouldn't be waiting for me to do this. You guys can do this on your own. You guys can try this on your own. You should be doing this with me. I shouldn't be the only one doing these calculations. And I would get x equal to, I'm going to divide both sides by 98.86 because it is multiplying by x, and that's the opposite. And I'm going to get x equal to, we need to round, it says predict the day, so we need to round to a whole day, to 14 days. X would equal 14 days. So on the 14th day, they have reached their goal. Now, using the equation from part A, so same equation, predict the number of coats, so I need to know this, y equals, I don't know how many coats, and day, this is going to be my x, we'll have on the 12th day. So we're going to do y equals 98.86 times 12 plus 737.33. Now I promise to show you how to do this in Desmos. So I'm just going to go to a new line and type this in as it's written on my paper without the y, because the y is not necessary now. 737.33. And I get that number. It says equals right here. So it's y equals 1923.65. That is my answer. And it should say coats at the end of that. Okay. Now, question number 4. A research study finds that fat calories in hamburgers have a positive linear association, meaning that it looks like this. Positive linear association. So as x increases, y is also increasing. So they're doing the same thing. The finding indicates that, we're going to choose the best answer. So it's amounts of sodium found in hamburgers. Fat calories have a positive linear association with the amount of sodium. So this is fat, sodium. So the higher the fat, the higher the sodium. Low amounts of sodium in hamburgers indicates a high number of fat calories in hamburgers. No, it's not going to be opposite when it's positive. It's opposite when it's negative. High amounts of sodium in hamburgers cause high amounts of fat calories in hamburgers. Maybe. Hamburgers with low amounts of fat calories tend to have low amounts of sodium. Maybe. Hamburgers with low amounts of fat calories tend to have high. It's definitely not that. Well, the fat calories is the independent variable. So it's the one doing the causing, not the sodium. So that's why it can't be B. High amounts of sodium is not causing the fat. The fat calories are causing the high amounts of sodium. So C is your answer. When one is low, the other is low. All right. We have one more problem. It's kind of a big one, but we only have one more problem. As the number of farms has decreased in the United States, the average size of the remaining farms has grown larger, as shown in the table below. So these are the years, year, time, that has to be your X, and the average acre per farm has increased. So as one increases, the other increases. If they're both increasing, think about what type of correlation do you have? You have a positive correlation. First of all, make a scatter plot of the data, letting X represent the number of years since 1900. So this is 1910. How many years is that past 1900? Well, it's 10 years past 1900. So 139 is my first one. And again, I got 10 as my X because 1910 is 10 years past 1900. And it says let X represent the number of years past 1900. Essentially, this is going to be 10, 20, 30, 40, 50, 59, 69, and so on. We're just going to take the 19 off. The next one is 149. And then 30, 157. And then 40, 175. And then 50, 216. And then 59, 303. And then 69, 390. And then 78, 449. And then 87, 462. And then 97, 487. Okay, so we have our scatter plot made. Using a graphing calculator, we're going to use Desmos. Find the line of best fit, rounding to the nearest hundredth if necessary. Line of best fit, remember, is M and B. We need to find our slope equation, our slope intercept formula equation. I'm going to get rid of this. This one is going to be not weight of a panda like it was last time, but it is average size of farms. Remember, you can title your graph by clicking that on the left. I am going to show you how to do something else today that you're going to need to know for your project, so make sure you're paying attention. So the first one, remember, it's years past 1900, so it's 10, 139, 20, 149, 30, 157, 40, 175, 50, 216, 59, 303, 69, 390, 78, 449, 87, 462, and 97, 487. All right, now remember I told you that you could zoom fit that little magnifying glass on the left at the bottom of your table. It says zoom fit. I'm going to click that so it fits my data to the graph that I'm seeing. All right, and like I said, we need our M and our B. So my M, we're rounding to the nearest hundred, is 4.72. And my B is 37.93. Let's look at our R real quick. Our R is 0.96. That's our correlation coefficient. It's positive, which means we have a positive correlation, and we do because it's an increasing line. And it's really close to 1, so this is a strong positive correlation. All right, coming back over here, let's write our equation. Y equals 4.72 x plus 37.93. All right, let us talk about what this means in context. So in year 0, which would be year 1900 for this, the average size would be 37.93 acres, or around 38 acres. And then the slope, what does this mean? As each year progresses, or as the years increase by 1, the acreage of the farms increases by 4.72, or about 5 acres. That's what this means in context. So predict the average acreage in the year 2000, round to the nearest whole number. So the year is 2000. How many years is that past 1900? Well, it's 100 years past 1900, and years is X. And I need to know the acreage. Acreage is Y, so I'm trying to find what Y equals. So Y equals 4.72 times 100 plus 37.93. Let's put this in Desmos. Scrolling down, adding on. 4.72 times 100 plus 37.93, and I get 509.93. So Y would be 509.93 acres. And it says round to the nearest whole number, so that would be 510 acres. The next one, predict the average acreage in 2010. So how many years past 1900 are we at? We're 110 years past, and we're rounding to the nearest whole number again. We're finding Y this time again, because X is 110. So Y equals 4.72 times 110 plus 37.93. Cool thing, we can just take this 100, cross out, and put 110. Make your life easy. And I get that Y is, now remember, rounding to the nearest whole number, 557 acres. And you guys can see that on the graph. Like at 100, we would be right here, which is 509.726. And at 110, we would be right here, which is 556 around. Rounding up, 557. So you guys can also see on your graph, you don't have to always do just the calculations. Your graph can tell you too by tracing along the line. All right, last one. What was the average acreage in 1810 to the nearest integer? So 1810, how many years from 1900 is 1810? Well, it's negative 90 years because it's 90 years before 1900. Is this reasonable? Explain why or why not. Well, let's see. This is going to be my x, negative 90, and I'm going to find y. So y equals 4.72 times negative 90 plus 37.93. Let's go back to Desmos and just change that 110 down here to negative 90. And I get y equal to negative, we're going to round to the nearest whole number or integer, 387 acres. Does that make sense? Negative 387 acres? No. Because you can't have negative acres. It's just not possible. Can't have negative land. So it's not really a reasonable explanation. So there must be somewhere where this levels out at some point. Not from what we see, but where we can. Now, the other thing I want to show you in Desmos is if you go up to this right-hand corner, there is a square with a little arrow, and you can press it and it says Share Graph. And then what you can do is you can copy this link and send it to me. You can put it in a document. You can do whatever you need to. You could print it if you wanted to. So if you ever need to send me a graph that you made on Desmos, you can always share the graph and send it to me. I hope you guys have a wonderful day. Like I said, if you need any help at all with the project, I'm here. You guys all have different information, so it really doesn't help you to look with someone else. But answer the questions, do your best, use Desmos, rewatch the videos as you need to. I hope you have a great rest of your week.